Hello, Griffins. Today, acid-base titration lab. We are going to work out the background, the purpose, the procedure, and how to do a titration. While I'm up close up this side, I want to show you real quick. This is a burette. Notice when I'm perpendicular, I'm closed. This is when the burette is open and will just be dispensing liquid. So you should all be able to see that. The other thing, I don't know if you can see, but I'm up close to try and show you, is that this graduation goes opposite of a graduated cylinder. It starts at 0 and goes to 50 so that I can fill it up, figure out where my starting spot is. When I'm done, I can figure out how much I dispensed. So I'll need to know that for the lab. Okay, I'm going to go back, set it back up over here and show you how to do this lab real quick. There's a few things we need to know and be able to do. So first of all, background. The background information has to have something about a neutralization reaction. What do I produce when I do a neutralization reaction? What is the pH of a reaction, like the product, when I do a neutralization reaction? And something about indicators. Indicators do what? So those are all. That's the background. You answer all those questions. Purpose. Purpose of today's lab is to find the concentration of this unknown acid. I will not tell you the concentration of the acid. Okay, I will tell you the concentration of the base. It's 0.5 mole. We'll need to know that, okay, for our calculations. So on to the procedure. When you come to see Mr. Milks, show me that your background, your purpose, and your procedure are all set. I will give you acid and base in a beaker. So I'm going to go ahead and give acid and base. I'm only going to give you about 40 mils of acid because you're going to titrate 10 mils at a time. Do I need to say that again later? Probably. About 10 mils at a time. So there's the acid. You're going to need a little bit more base because we're going to titrate this thing 3 times. Okay. There is only one beaker of the phenolphthalein indicator right from the indicator lab that we did last week, and that's here. This will be over by the windows. We're going to have to share and play nice. Okay? Got it? Play nice. But we're actually not going to play because this is science lab. So next things last. Base goes in the burette. Ready? Say that with me now. Base goes in the burette. BB. So I got a funnel. I'm good. It's closed. I'm going to fill up the burette with base. If we all stick to that, I don't need this emptied every time. So if you come up to the burette, you should have base in there and know that you have base in there. Now, what I did was I overshot that 0 a little bit. I personally would like it to be right at 0 to make it easy for me. Get out my bubbles, back into the base I had. I'm going to let a little base out until I get down to that 0 line. Okay? Which, in case you can't see, is right about here. Notice I am going to keep my eyes focused on this while I turn. I might not be dispensing any at all right now. I don't see it moving because I want to get that meniscus right to the line. Once I get it going at a slow rate, like it's going now, very slowly, I'm going to let it go. I'm not going to open it up anymore. I'm going to wait. It's getting there. It's getting there. Bam. Bottom of my meniscus is right at the 0 line. So when it says volume of unknown acid, we're going to do that in a second. Initial burette reading, I just set it to 0. So my initial burette reading is 0. Okay, so I'm good. Now I'm good with the base. Now I need 10 mils of acid per titration. 10 mils. You need to know the volume of acid. So I'm actually going to see if this takes too long, Matt. If you want to pour it in, I guess you can, but you really risk overshooting it. Notice my eyes are at the level that I'm reading it. I'm not picking this thing up. I need that meniscus to be right on the 10. Bottom of the meniscus. Okay, now I'm at 10 mils. So that's good. The 10 mils goes into the Erlenmeyer flask. 10 mils. Okay. 2 drops of phenolphthalein should be more than enough. 1, 2. We'll swirl around. Okay, now I'm going to actually titrate. I'm going to titrate until this is where we compete for the lightest pink possible. I'm going to shoot it fast so you see the pink. I think everybody on camera can see that, and boom, oh, see it go away? So now I'm not done. But that pink, by the way, was way too dark. We want to go for the lightest pink possible. So it's going to take some time for you to figure out how to do this. You may need to do it more than once. You see as I drip one at a time, I'm going to swirl. The white card is to help me see the color. It's hard to see pink on the black. It's a lot easier to see pink on the white. The white also helps one other thing. Helps it so I can more accurately read the graduation on there. So here we go. I have reached my endpoint. As a matter of fact, I've blown way past the endpoint. And I didn't use very much base. So you should know right off the bat that you're not going to have to use very much base. Okay, so this particular, if this was my first run, I would probably dump this in the waste beaker, rinse this particular Erlenmeyer out, and do it again. You're going to repeat this 3 times. You also need to note at the end of each trial what the new volume of the base is. So back to this trial. I know I put 10 mils of acid in. I had an initial reading of my burette, which was 0. I have a final reading of my burette when I'm done and I'm happy that I've titrated this properly. And that's what I need. Then I can figure out what the total volume is, which is the final minus the initial, and I'm off to the races as far as calculating concentration of my acid. It's plug and chug from there. I'll know all 3 values I need. I got volume, I got concentration, solving for the other concentration. You're going to do this 3 times at a minimum. I just now have a new starting point for my base as far as milliliters goes. You do not need to fill this back up to 0 every time. Just start with a new starting point and a new ending point and do the calculations. You can top the base off at the end if you want, but you can leave that up to the next group too. So we just went through the whole lab. How we're going to do it, you got some analysis questions you got to be able to do, and your CEI. Your claim is a statement. The concentration of the unknown acid is, boom, it's a number that you calculated. I know my claim is accurate because how close were your numbers to each other? Cite 3 trial results and the average. Were they consistent or were they sloppy? Then interpretation is your percent error. There is a spot when you're done, when you have to come and see Mr. Milks, and I'm going to give you the actual concentration of the unknown acid. But I'm not going to do that until you have done all this work and figured out what the concentration is yourself. This way, now you can compare the known value to your value and come up with percent error for your interpretation of how well you titrate. Remember, leave a nice clean station. There are 4 stations we have to share, so 4 groups can go at a time. When you're done, I expect your station's nice and clean so that the next group can come right in, get their acid base, and get right to work. Okay, any questions? We'll talk in class tomorrow. See you.